You ever been stuck in traffic, just staring at the car in front of you and wishing you could just, fly over all of it? Well, that dream is getting so much closer than you think. But the real revolution isn't just the flying car itself, it's the invisible network that's going to make it all work. So today, we're going to dig into the Smart Airspace, the AI-powered grid that will manage our future skies. For decades, right, the flying car has been pure science fiction. But now, a whole bunch of new technologies are coming together and actually making it a reality. I mean, just imagine cutting your commute from an hour down to, say, 15 minutes, or being able to get to a remote spot without a crazy long drive. That's the promise here. And it's about so much more than just the vehicle. This whole revolution in the sky has a name. It's called Advanced Air Mobility, or AAM for short. And it's a totally new way of thinking about aviation, designed to move people and cargo in ways we've only ever dreamed of. So what is AM, really? At its heart, it's all about using these super advanced aircraft, like electric vertical takeoff and landing vehicles. You'll hear them called eVTOLs, to build a transportation system that's just faster, easier to access, and way more sustainable, especially for getting around our cities. And look, the promise here is, well, it's huge. We're talking about slashing travel times, we're talking about connecting isolated communities that have kind of been left behind, and maybe, just maybe, finally freeing ourselves from the traffic that just drives us all crazy every single day. So, what's the secret sauce making this possible? It's a technology called distributed electric propulsion, and this right here is the real game changer. It basically frees aircraft designers from the old rules of mechanical engines. They can put multiple electric motors anywhere they want on the aircraft, which unlocks these incredible new designs that are way more efficient and safer. But this brings us to the billion-dollar question. I mean, it's one thing to build a cool new aircraft. It's a whole other thing to manage a sky buzzing with thousands of them, all flying at low altitudes right over our cities. How do you stop a traffic jam in the sky? Or, something much worse. The answer isn't a bigger control tower with more people staring at screens. No way. The solution is a new, intelligent, and pretty much invisible network in the sky. It's an automated grid that we're calling the Smart Airspace. Okay, so any smart system needs two basic things: a way to get information and a way to make decisions based on that information. Think of it like nerves and a brain. So let's start with the nerves of the Smart Airspace, the communication network that ties everything together. Now, check this out. What's so cool about this diagram is that it shows this really complex, multi-layered network. We're not just talking about a plane talking to a tower anymore. We're talking about everything, from big cargo planes way up high to tiny delivery drones down low, all communicating with each other, with satellites and with stuff on the ground. This whole network really stands on three key pillars. First, you've got satellites, providing universal navigation and data links, so every single aircraft knows exactly where it is all the time. Then, on the ground, powerful 5G and eventually 6G networks give you that super high-speed connection you need in busy cities where thousands of these things might be flying around. And finally, you have what's called aircraft-to-everything, or A2X communication. This lets the vehicles talk directly to each other, creating this self-organizing web that can react to things in real time. Okay, so we've got the nerves. Now for the brain of the whole operation, the artificial intelligence that's going to be the ultimate air traffic controller, making millions of split-second decisions to keep everyone safe and on time. Now, when it comes to this AI brain, researchers are looking at two main approaches. The first one is a centralized model. Think of it like a single super smart AI on the ground playing chess with the whole sky, controlling every single piece. The second is a decentralized model, where each aircraft basically has its own brain, making its own decisions based on a shared set of rules and talking to the other aircraft around it. So how do they stack up? Well, NASA has run some incredibly complex simulations to figure that out. And as you can see, if you don't have an AI controller, the number of potential collisions, what they call a loss of separation, it just goes through the roof. But look what happens when you turn on either the centralized or the decentralized AI. The potential for collisions drops to almost zero. The bottom line is, both systems are incredibly safe, and that's priority number one. And what about efficiency? Well, the centralized system has a slight edge, because it can see the whole picture like a god's eye view. It can make slightly better decisions, meaning aircraft have to fly a little less out of their way to avoid each other. But as you can see, the difference is really, really small. But, and this is a huge but, there's a critical trade-off. As this NASA researcher points out, decentralized systems are way more resilient,
Because each aircraft makes its own decisions, the whole system doesn't rely on a perfect, constant connection to some central computer on the ground. If that connection is lost for a second, the aircraft can still keep itself and everyone else safe. And that's a massive advantage, especially when you're flying over a crowded city. All right, so we've got the technology for the vehicles, and we have the concepts for the AI grid that's going to manage them. So let's zoom back out and look at what it will actually take to make the smart airspace a reality in our cities. And this right here, this perfectly illustrates one of the first big physical challenges. It's not just about putting more 5G towers on the ground. To get seamless coverage, you have to think in 3 dimensions. You've got to figure out the perfect altitude and placement for airborne communication hubs, like drones or balloons, to fill in all the gaps. Now, this is not going to happen overnight. The rollout is going to be gradual. We'll start with operational testing and piloted cargo delivery over the next decade or so. Then, as the tech and the rules mature, we'll start to see a move towards fully autonomous systems for both passengers and cargo. It'll probably become a pretty common sight in our skies sometime after 2040. But, the path forward isn't exactly easy. It's going to require massive investment in infrastructure, like building all the vertiports for takeoffs and landings. It means writing a whole new rulebook. We'll need much, much better low-altitude weather forecasting. We've got to make sure there's enough wireless bandwidth for all this data. And maybe most importantly, we have to earn the public's trust. So, are we ready for this?
So the big takeaway here is this. The future of flight is actually less about the shiny new vehicle and more about the invisible intelligent network that's going to manage everything. The technology for the smart airspace is pretty much here. The real question now is, are our cities ready for it? Are we ready for it?